All right, so I typed it out here so you have it right in front of you, but it says, suppose the average yearly salary of an individual whose final degree is a master's is $45,000 less than twice that of an individual whose final degree is a bachelor's. So sometimes these word problems, you really have to like take your time, read through them carefully, and try to make sense of how I'm going to set this up. Because there's a lot of information here. They're talking about people with master's degrees and how much money they make, and they're comparing it to people who have bachelor's degrees. So you have to kind of, again, read through it carefully and figure out how to set it up. So it says the people who have master's degrees, their salary is, okay, so master's degrees, I'll just put M for master's degrees. How's that sound? Then what about the word is? When you see that in a story problem, what do you think is means? Yeah, I remember that even from when in elementary school, when I learned how to read a story problem. It's like, oh, when you see the word is, that's an equal sign. So the master's degree is 45,000 less than. What does like less than mean to you? Yeah, subtract, like take away 45,000, like 45,000 less than. So it's going to be like minus 45,000. Because it says 45,000 less than something. Less than what? Less than twice that of the person who has the bachelor's degree. It says individual whose final degree is bachelor's. Twice that of the bachelor degree person. So, yeah, like 2 times B or something like that. Because it's saying like 45 less than twice the bachelor degree person's salary. So you got to just take your time and read through it. And then, did they tell you, if you keep reading, did they tell you how much a bachelor's degree person makes on average? Yeah, but it says combined. Okay, so bachelor, good job. So bachelor's, we're just saying that's like B. We don't know how much they make yet. And then we did the master's, and I wrote that at the top. That was like 2B minus 45. Oops, 2B minus 45. But then you're right. Then it says together, it tells you their total. It tells you the bachelor's person and the master's person together make 117,000. So it's like called like a system of equations because we know like each person, like a little equation for each person, and then we know together a bachelor's degree person and somebody with a master's make 117,000. So now you can use these definitions over here for bachelor's and master's. So like for that M, for that master's person, we know that was 2B minus 45, so you could plug that in. So that's the kind of stuff you're going to see when you get to working on your assignment. It's a system of equations. So you have to think of each person or each scenario, and then, yeah, a lot of times they put it together. So now you put in B plus, for the master's you put in 2B minus 45 equals 117. And then solve from there. The letters on the one side of the equation you can put together then, because this is 1B plus 2B, so that's 3B. And the 45, you could add 45 to the other side. So you'd have 3B equals what? Let's see, 117 plus 45, 162, I guess. I just grabbed my calculator and punched it in. Then divide by 3 and you'll get the answer. You'll get one of the answers. You'll get 54. That's for the bachelor's degree person. And then don't forget then, you're going to have to find the other answer too, how much the master's degree person makes, because they'll ask you at the end like both answers. So how do you find the other person's? Yeah, plug this 54 in. So like 2 times 54 minus 45, or over here. Yeah, plug the 54 in to get the master's degree person. 2 times 54 minus 45. And we'll have to get that. Oh yeah, you could do that too. Yeah, I didn't think about that. I know, sometimes, there's more than one way. So Medhani was saying you could just plug it into this problem too. Just take 117 minus 54. That's another way. Yeah, I wasn't even thinking of that one at first. I thought of the hard way. Yeah, there's more than one way to get the answers at the end, because there was several equations we used, so you can just plug it back into one of them. Good job. So you'll see different story problems like this when you do your homework. Here's another example, something kind of similar to what you're going to see on your assignment. So in 2005, there were 14,500 students at College A. So they have College A in here, and they talk about College A, and they have a projected enrollment increase of 1,000 students per year. And then you keep reading, in the same year, there was 40,000 students at College B. So there's College B. And they have a projected enrollment decline of 700 per year. So we need to make equations for this again. So when you do your homework, you're just going to have to take your time and read these things through. So this one's talking about College A and College B. And we need a little formula for each one. So College A, they said there was 14,500 students at College A. It says it right up here. But then they're talking about in the future, as you keep, over the years, they have a projected enrollment increase of 1,000 students per year. So they think their enrollment's going to go up. See, increase, like go up by 1,000 students per year. So what should we put at the end of that if we think it's going to go up by 1,000 per year?
1,000x.
Yeah, 1,000 times x. You need the variable because it's like times however many years. X is like for years, standing for how many years there will be. 1,000 each year. And then same thing with letter B, College B. You got to read through their information. It says that college has 40,000 students. At College B, 40,000 it starts with, but this one says it's going to decline. So decline, go down minus what? 700x. Okay, now the thing about this problem, I guess, is now we just read what they want you to find. According to these projections, when will the colleges have the same enrollment? What's the same mean? Yeah. I'll write that down in red. Equal them. They want to know when they're going to be the same, so equal these to each other. That's what you want to do. You want to equal this 14,500 plus 1,000x equals 40,000 minus 700. You're going to want to equal them. So look for problems like that. If it says the same, you're equaling something. So 14,500 plus 1,000x equals 40,000 minus 700x. Yep, you're going to equal those. Okay? And then solve it. So I would add the 700x and get your variables on both sides. Get them to one side. So I have 1,700x. Then I'll subtract the 14,500 from 40,000. Kind of do the two steps. So 40,000 minus 14,500. I got 25,500. Then finally divide by 1,700. 25,500 divided by 1,700 equals, I got 15. Okay, good. You got the same. Okay, now you're gonna have to be careful when you read the assignment and try to do the assignment. 15 actually isn't the answer yet, because on the assignment, I looked at your assignment. It asked you like, what year did this happen? What year was the enrollment the same? So what year it's gonna say. Yeah, so this means like 15 years later. This means after 15 years it was the same. So look back at what year it started. It started in the year 2005. Yep. So what year is 2020? Yep, good job. So just be careful of that. That's why I put this one on the note sheet and wanted to talk about it, because sometimes you get the answer X and that's not the final answer yet. They want to know what year it actually was. And then finally, it also has a second part to that. They're going to ask you what year, and we figured that out. And then they also ask, so what will the enrollment be at that time? What will the actual answer be at that time? When X is 15 and when 15 years go by, what's actually the enrollment? So you have to take this 15 and do what? Yeah, go back to one of the problems and plug it in and find the actual enrollment. You can plug it into either problem you want, you just have to plug it back into one of the problems and get the final answer for what the actual enrollment is. So it's 15 for X, plug it in. Yeah, 29,500, good job. You plug it back in, you get 29,500 people, students enrolled. Yep. So there's two-part, and that comes up on the assignment. I know there's a one like that with a two-part like that, like what year and what's the answer. If that was the year, then plug it in and find the actual answer. Okay, almost done with these. Halfway through here. Sales tax. I think a lot of you are familiar with sales tax and discounts at stores and stuff. But just to set these up, sometimes just going over the setup. So this says you're like renting a hotel room, some inn you're staying at, and they charge $207.90, but that's with tax. Including the tax, it's $207.90. Find the inn's nightly cost before the tax was added. So you need to think of it like this. Like the inn had a cost before the tax was added. Like the inn's nightly cost before tax, you could say that's X. You know? Before they add anything. So before they added the tax, it was just like some certain price. That's what we're trying to figure out. What was the X before they added the tax? Well, then they added tax. Tax is always added. And the tax that's added, it was 5%. So you need to know how to make 5% into a decimal.
0.05.
Yeah, most of you know that. Good job. It's 0.05. You move the decimal back twice or divide by 100 is the same thing. Good job. So they're adding not just 0.05, but 0.5%. It's 5% of whatever the cost was, like 0.05x. So this is 1x. That's the cost of the hotel. And then they added 5% of the cost of the hotel. You know, like 5% time. You know, that's how they get the 5%. They take it times something. So this is like 1x plus this is representing adding 5% of the price. And then the total cost is $207.90. So just remember that it's like the cost plus the tax, or the cost of the item minus a discount, or whatever it is in the assignment. It might be like minus 30% off or something. But anyway, you add that up and it's 1.05x equals $207.90. See, you have to put 1 for the actual cost of the hotel, the 1x, that's the cost of the hotel, and this 0.05x is the tax. And you add it up, 1.05. Now you divide by 1.05, 1.05, and you'll get the actual x, the cost of the hotel, before they added the tax. So 207.9 divided by 1.05, 198. So the cost, the hotel was $198 before they added the tax.
Isn't that like, wait, is it like $10? It's a little less.
Yeah, like the tax on the, yeah, it was like 198. Yeah, it was 207 with the tax, 207.90, and without the tax it was 198. Yeah, it's about, yeah, just under $10. You're right. It's like $9.90 was the tax. Yep. And then finally, on lesson 1.3, there's going to be questions with solve for a certain variable. Like this one, solve for s. So find the s in the problem. It's right there. You want to leave the letter s alone and move everything else away from it. You're trying to solve for s. So you leave the letter s alone. You want to get all this other stuff away from it. Like you don't want this 1/2 h next to the s. You don't want the k over here. You're trying to solve for s. That means like get s alone, right? That letter s, you're trying to get it alone by itself. So how do you get rid of the 1/2 that's in front? You got this problem, it has a 1/2. I don't want the 1/2 in front of this times the s. I don't want the 1/2 there. Yeah, you multiply by the reciprocal. So you multiply by 2. Because when you take 2 times 1/2, it like cancels out. See, you times by 2. Because 1/2 is like 1 divided by 2. So opposite of dividing by 2 is times by 2. The inverse of that. Okay, so if you times by 2, it gets rid of this 1/2. Now you just have h parentheses s plus k equals 2b. How do you get rid of the h that's in front? H times that parentheses. So yeah, I heard 2 different answers. I heard divide and I heard distribute. We don't really want to distribute because we're trying to get rid of the h, like move it to the other side of the problem. If you distribute, it's more work, then you'll have to factor it again. Like you'll have to pull it out again. So you don't really want to distribute in this case. You distribute a lot if you're trying to solve a problem, but when you're trying to get a letter by itself, it's just like move it, get this h out of here, like cancel it out right away. Don't distribute it, just get rid of it. So distributing would actually be more work. There's a lot of times in math where you do want to distribute, like if you have more problems with numbers, you want to distribute the number through, but not in this case. You want to just get the h out of there to divide it. So now you have 2b divided by h equals s plus k. Now you don't really need the parentheses around the s plus k anymore. The only reason it had parentheses over here because it was times with the h. So now you don't really need the parentheses around s plus k anymore. And we're almost done. We're trying to get s alone. Try to solve for s. So what's the last step? Subtract k. So the answer is 2b divided by h, and then just minus k after it equals s. See, that's the answer. You get the s by itself. You get the letter s by itself. 2b divided by h, and then subtracted the k. So that's what lesson 1.3 is about. It's about story problem type things like that and formulas, using formulas, solving for a letter. And then 1.4, we're going to talk about that a little bit too. 1.4 is about imaginary numbers, complex numbers. And I know you've seen them before, but just to refresh on them a little bit. 1.4 is on complex numbers. And once you start seeing it, you're going to be like, oh yeah, I remember those from last year, or 2 years ago. Algebra 2, some of you had it last year, or some of you had it 2 years ago. Alright. We don't have a lot of notes on this section either, just we'll try to get through it quick. This section is about imaginary. Complex is like talking about those imaginary numbers. So there's an imaginary unit we've seen before. It's I. When you see that letter I in math problems, do you remember what I stands for? Square root of something. -1. That's the imaginary unit. complex numbers. I stands for square root of negative 1. That's I. You started learning about it in Algebra 2, so you could deal with square roots of negative numbers. Also, in Algebra 2, you talked about I squared. So like if this I, if it was like square root of negative 1, we know I is square root of negative 1. Do you know what I squared is? Yeah, I squared is negative 1. Because if you took like the square root of negative 1 times another square root of negative 1, it's just negative 1. It gets rid of the radical. So we learned about this I thing to deal with things like square root of negative 25. So we could actually write an answer for square root of negative 25 instead of saying no solution. Because if you grab a calculator, you've seen this before, if you grab a calculator and type in square root of negative 25, it's going to say error. It doesn't work. But we learned about it so that we could actually say an answer for this. What's the square root of 25? 5. And then it has this negative in there. Yeah, so that's the I part. It's like, see, it's like negative 1 times 25. So the square root of negative 1 is I, and square root of 25 is 5. So the answer is 5I. Yep, the answer is 5I. So you're going to be seeing these imaginary numbers on lesson 1.4. You need to be able to add and subtract them. So we'll go over one of those. Add and subtract. Like if I had 5 minus 11I plus 7 plus 4I. You're going to have to be able to add and subtract complex numbers. So you'll see there's like a regular number part in there. Like there's numbers in there that don't have a letter I. And then there's the part with the I, the numbers that have I. So they say that the plain numbers are like the real numbers, and the part with the I, that's imaginary. So you can add the real parts, and then you can add up the imaginary parts. So do you see some real numbers that you can add up? Yeah, just the normal numbers, 5 right here, 5 and 7. So you just do 5 plus 7. What's that? 12. Okay, that's easy. And then I'll just like put an arrow pointing at them. Then do you see those other things have I? That's the imaginary part. Can you add the imaginary parts of the problem? But see, it's negative 11I plus 4I. What's that? Negative 7I. And that's it. That's it. See, you know what a big mistake is? People see this problem and they want to start multiplying it. But see, in the middle, it's just add. It's just add in the middle. Because that's the mistakes I see, just common mistakes all kinds of students make. They see this problem, and I see some people trying to do like times multiplying. I'm like, this isn't a multiplying problem. This was just add the 5 and the 7 and add those and you're done. So I think sometimes people like get carried away. They think it's going to be more than it is. This one's pretty simple. Just add the real part and add the imaginary numbers. And they're going to tell you on this assignment to have your answers in A plus BI form. Answers have to be in that format. And our answer that we just wrote is the one we just did. It has the real part, the 12 is like the A, and the 7I, see that's like BI. The answers on your assignment, this is the kind of like the standard form for these. A plus BI form, that's the standard form for complex numbers. Okay, then they'll get into multiplying them. But see, the one we just did had a plus sign in the middle. That was just add. So the difference is with multiply, how do you know it's going to be a multiply problem? Well, it could still have the parentheses, but it won't have anything between the parentheses. So let's say it had something like this, parentheses 7 minus 3i, and then another parentheses, -2 minus 5i. So you see, this one's a multiplying problem because there's nothing in the middle right here. That's times then. So you gotta look at, when you do your assignment, I'm trying to warn you ahead of time because I know some students will start trying to multiply this one up here. I'm like, no, it's just add. It's just add on that one. Okay, this one's multiply. So you need to do, like we've talked about, like FOIL, first, outside, inside, last. Multiply all 4 things. First, 7 times -2. That gives you -14. Then the outside, 7 times -5i, so that'd be -35i. Then the middle, see, then the inside, what do you get when you times the inside? 6i. And then you do last, the -3i times the -5i.
Plus 15i squared.
That's 15i squared. Good job. Because see, that one's I times I, so that one's I squared. Okay, then I'll just underline these in red. See these ones that say I? You could put those together. The ones that just say I, not the I squared one, just these 2 in the middle. So we have -14 still. What's -35 plus 6? -29i. Okay, plus 15. All right, what's I squared equal? Look back up here. This I squared, yep, that's -1. So you'll have to remember that up here. I squared is a -1. So it's really minus 15 now. See, it's minus 15. So whenever you get an I squared in a problem, it turns to a -1. Now you can put the 14 and the 15 together. Yep, -14 and -15. So your final answer is -29 minus 29i. Because 14 and 15, if you put those together, you get -29 and then -29i. So you have multiplying ones like that to do. And then the last kind you'll have is dividing ones. We'll do one dividing one. I'll just do a new page so I have room. Or did everyone get that one? So I have one last one. Very, very last one, and then you'll just have work time. Last one is if you have dividing problems. So 7 plus 4i over, like, divided by 2 minus 5i. Okay, so it'll say simplify this or divide it. You don't actually divide. It's kind of interesting. You don't start dividing 7 and 2 or anything like that. You don't actually divide. You actually end up multiplying by the conjugate. We already talked about that with like radicals and stuff. You do the same thing when you have these imaginary numbers, these complex. You multiply by the conjugate. You look at the bottom of the fraction to find the conjugate. A conjugate's like an opposite. So the bottom of this fraction says 2 minus 5i. What's the conjugate of that? 2 plus 5i. That's right. You multiply by a conjugate. 2 plus 5i. And these will be the hardest ones. You just got to remember that rule. Multiply by the conjugate. And you have to distribute this all out. FOIL again. First, outside, inside, last. You're going to have to, like, I could put parentheses around it. So you're going to have to do first, 7 times 2 on the top. That gives you 14. You got to take your time. Then you got to do outside. So that'll be 7 times 5i. So 35i. Then inside, see in the middle, 4i times 2, so that's 8i. Then last, up there in the top, last is 4i times 5i. So that's 20i squared. Okay, then you have to do the bottom too, and then we'll have to add stuff up. It's a lot.
Why don't those cancel out?
Some of it will. Yeah, some of the bottom's going to cancel out. That's good. So you start multiplying the bottom out, like 2 times 2, that's 4. And then you do 2 times 5i, so that's 10i. Then in the middle, it's negative 5i times 2, so it's negative 10i. So yeah, Fabiola was saying, like, she's asking some of it's good. She was asking if something's going to cancel. Yep, see? So you get 10i, and then you get negative 10i, and then finally you times the last ones, and you get negative 25i squared. So yeah, the 10i and the minus 10i cancel each other. That cancels out. So we're getting there. And then you have to remember the fact that I squared equals negative 1. So when you see these I squareds, those are negative 1s. So it turns it to, at the top right there, it'll be like minus 20. So it'll be easier. So we have 14 on the top. We could add the 35i and the 8i together. So you get 43i and then minus 20. Like I was saying, and the bottom you'll have 4. What happens with this 20 minus 25i squared? Yeah, it'll be plus 25. Because the I squared, see, it's a negative 1, so 2 negatives make a positive. Okay, almost done. 14 minus 20 on the top. That'd be negative 6 if you put the 14 and the minus 20 together. Negative 6 plus 43i, and then you add up the bottom and you get 29. Okay, now on the assignment, like I was telling you just a minute ago, they want the answer in a plus bi form. The final answer, they want it in this a plus bi form. This is close, but not quite. In the a plus bi form, it's actually really easy. We almost have it. Do you see how it's over 29? Just put each of these things on the top over 29. Just write it like individually, like negative 6 over 29 plus 43 over 29i. That's how they'll want it on the assignment. The final answer in a plus bi form. They want it like separated. The real part of the problem with just the plain numbers, and then the second part is the I. The imaginary part. Real and imaginary. That's how they separate it. So it's just making 2 separate fractions over 29. Yeah, those will be, like, they take the longest. See, they're like the most steps.
So the I goes outside, like, could be like a negative sign inside, or does it go over 43? Like, once you put it in fractions, does it just go inside?
Yeah, I just put 43 over 29 and then just like a letter I after it. Yep, just like after it. Yeah, so that'll be the hardest ones, the dividing, because it's just the longer ones. Alright, so you got the idea that square roots of negative numbers, that's the I. See, like that. Alright, so you have time to work on things. I'll come around and help you guys. I'm sure that sometimes you'll work on ones and you'll get stuck and I can help you out.